Hello, my name is Stephen, and in this tutorial we are going to be taking a look at how to use shaders in Wade. So the first thing we need to do is open our web browser. We need to navigate to www.clockworkchili.com/Wade. And I'm just going to go ahead, press F11 here to full screen and give us a bit more room. Now, we're already watching a tutorial, so obviously we don't need this screen. We'll just click Skip Tutorials and create a new project. And I'm just going to call this... Actually, no, we'll call it Water, because we are going to be creating a shader to create a water effect, which you can use in your games. So, first of all, we kind of need to see what a shader is, and we also need to do some basic housekeeping here. So, we're just going to set the min size and the max size to 1280 by 720. I do this in all the tutorials just to keep it simple and consistent. So now we've done that, let's just go ahead and save what we have. And currently what we have is an empty scene, so we're just going to go here and click New Scene Object. And this creates our familiar white sprite. We can change the size of it, we can zoom in, zoom out, whatever we want. I'm just going to put it there, that's nice and big. So now we've just got the white sprite. It's a bit boring, but what we can do is we can add our shader. So down here you see Custom Pixel Shader. So I'm going to go ahead and click that, and the code you write in here actually gets compiled and executed on the GPU itself. These shaders are called pixel shaders primarily. They're also known as fragment shader. But basically, it's a little program, a piece of code, that runs for every single pixel that the graphics card has to draw. And this is very useful if you want to do some crazy cool effects, or just a basic water effect, which is what we're doing now. So you need to be familiar with a few things to use these. The first is how to actually output, like what is this shader going to output? There's nothing here. So shaders have a property, gl_frag_color. Now that is the output color that we will see on the screen. So if I give this a color, we'll see it change right now. This is the OpenGL language, GLSL for shaders. I can't remember what it stands for, is it? Nope, don't know, you'll have to Google it. But anyway, if we set this equal to vec4, and I'm just going to go ahead and do a simple example here. Oops, that should be a comma. There we go, we see our square has turned red. Now, what is this vec4 thing? Well, basically it's an array of 4 floats. That's close enough. And it represents R, G, B, and alpha color values. So red is 1, and these values are normalized between 0 and 1. I know in other applications they go from 0 to 255, but almost everything in your shader is normalized. So if you do something wrong in a shader and like it just doesn't draw, it's probably because you haven't normalized a value. It's often the case. So here we've got 1 red, no green, no blue, and 1 alpha. So how transparent it is. Of course, if we make this completely transparent, we see nothing. If we make it halfway, we'll probably get a reddy brown. And indeed we do. So all you need to know about this is the output of the shader. And of course white is all of these set to 1. So, we can change the colour of the square, but that's not really that interesting. So instead, we're going to load in an image. So I'm just going to quickly Alt-Tab and drag this image I prepared earlier. This will be in the description below, you'll be able to get the image there. It's basically lots of different noise textures all composited together. So you get a texture of noise, it could literally be a picture of gravel or just something that's random and natural. And you put that in the red channel of the image, you get another one, you put that in the blue channel, and you end up having all these different noise textures in the same image. And when you apply it to the sprite, it looks quite interesting. So we'll just go ahead and do that. Noise.png. Oops, missed the dot. So I do that, and it hasn't found it. Or has it, you may ask? I almost confused myself. Now, of course, our current pixel shader is overriding this, so I'm just going to go ahead and delete that. And there we go. So if you don't enter anything in the pixel shader, it just runs the default one, which is what Wade would use normally to display your texture. So this is what the texture looks like, and it is a bit odd, but again, that is because it is just lots of different noise images added together. And before we can make much use of this, we need to learn about a few more properties in this pixel shader. So I'm going to go ahead and add the first one. So time. This will be the app time of Wade. So how many milliseconds it's been running. So you'll notice I have this variable UV alpha time. There are two variables that get included by default in your shader. We saw a different variable before, the output, GL frag color, that is in all OpenGL shaders, but Wade adds two more. So we've got UV alpha time, and this has four properties, X, Y, Z, and W. X and Y, as you might expect, are kind of where the pixel is in the image. So if it's the very top left pixel of the image, X and Y will be 0, 0. If it's the very bottom right, X and Y will both be 1. And obviously anything in between those values is a decimal. And those are the UV coordinates. So that's the first part. Z is the alpha, the current opacity. We're not going to be using that in this tutorial though, so we'll just skip straight ahead. W, like you can guess based on this assignment, is the current Wade app time. Now this is useful because a lot of shaders require a changing parameter so you can animate the effect. So for water, as we are doing here, you might want ripples, and that's why I'm storing this here. And also, just because it's useful, I'm going to go ahead and store the UV coordinates separately, just so I don't have to write UV alpha time each time, because it is a bit of a pain to write. Okay, you'll notice this is changing. It's mostly because the shader's invalid and valid as I'm typing, so that's why that keeps changing its appearance. Okay, now the next thing we need to do is we want our effect to look the same regardless of the screen size, so I'm just going to change, I'm just going to change the Y parameter here by, we're going to multiply it by a ratio. We're just going to take the screen size, the Y value of the screen size, so the height, and we're going to divide it by the width. So that's just going to give us a consistent aspect ratio. But you may ask, where is this screen size coming from? That is a good question, so I'm just going to go ahead and save this now. And I'm going to scroll down. You'll notice we've got this property shader uniforms, so UV alpha time is passed in automatically. We don't have to deal with that. However, we've got the screen size property, and I've just made that up right now. It doesn't exist yet, so I'm going to go ahead. I'm going to select vec2, and the reason for that is that's basically two floats. It's got an X and a Y. And, well, screen size has got two coordinates, X and Y, so we'll just do that. We'll call it screen size, and you see it gets added down here. I probably don't need to, but I'm going to set the initial values just to 1280 by 720 to match the project. There we go. Just going to go ahead and run our program, and oh, that's a bit small, so I think we're just going to go and make that 640 by 640, and we shall zoom out just a little bit. So if we run now, that's a better size. Now if I resize this window, it just resizes the square, but everything stays in the correct ratio. So right now I'm just going to go and re-add this that we had earlier, GL frag color equals vec4 1 1 1 1, and put a colon there. I'm just going to go ahead and save that. It doesn't actually look like that's taken effect, so what have I missed? Is there an error? Yes, we have. UV alpha time, that should not be UV. That's just me getting confused. This should be XY, so that was a mistake I made. Just a naming thing. So XY are the UV coordinates, and we're storing them as UV, so I just got the names a little mixed up. But anyway, we see even though we do have a texture on this sprite, noise PNG, it's displaying white, and that's because we have this line here. So I'm just going to make this window a little bit bigger, because we need to add some code. Now, initially we could see the texture because by default, if you add a sprite to a scene object in Wade, it renders the, like it knows you want to see the image, so it renders it with a default shader that you can't see here. So we are going to have to redo that manually. Now notice when I type something, this shader gets compiled every time you make a change, so you can see it in the preview here, so you can see live changes. So this isn't actually the output. At the moment the shader's not compiling, so ignore what it looks like for now. At the moment, without this line, we have just white. So we need to get it back to the state where it looks like this when the shader is working. So I'm just going to create a new variable, SO. This is going to stand for sample 0. So we're going to be taking multiple samples from our texture. And we need texture 2D. Now, I said earlier that you have 2 default shader parameters that Wade handles automatically for you. One is UV alpha time, which we've already talked about. The other is U diffuse sampler. And basically, this is the texture. This is the texture that is on the sprite. If you don't have a texture, then it's just going to be blank, so you won't be able to do this. But this is how you access the individual pixel data. And we need the pixel data at our coordinates for this pixel, so we just put UV here, and we put a colon there. So now we're back to the white. So why has that happened? Firstly, because this shader is no longer invalid. This is perfectly valid code, so it runs, this bit happens, and we end up with a white square. Now, just to prove that this is sampling from the texture, this is a color, so this vec4 is no different than this one, apart from it is the color value at that point in the texture. So I can just do S0, oops, sorry, there we go, S0, and we see, there we go, it is rendering our texture correctly. So we're just going to run that, make sure everything looks right. That looks right to me. It's fantastic. Now, I said with this image we have 4 color channels. We've got red, green, blue, and alpha, and at the moment you can see kind of a strange pattern because, again, these are lots of noise textures that are added on top of each other. And we're going to make use of these different channels, so we can have some noise animating one direction, some animating another. But for now, I just want to animate with respect to time. So at the moment, pretend this is water, it's not moving, it's not very realistic. So what I'm going to do is I'm going to sample our pixel data from a different location based on time. Now we're already getting time from this UV alpha time parameter. And I realize this sounds a little bit complicated, so it's okay, you can rewatch if you get stuck, but I'll try and take it slowly. I'm just going to add a bit of a position. So say we are at the top left pixel, which I previously said was 0, 0. If I add 0.5 to this, instead of getting the pixel at 0, 0, we will get the one somewhere around here, halfway across, 0.5. It's halfway between 0 and 1. I'm not going to be that precise. I'm just going to create my vector, and I'm going to do time times 0. Did I really just do that? Wrong times. Times 0.1. And I think the bracket's alright. And then we're going to run this to see if anything happens. I may have made a little error here. I'm just looking. What do we think? Oh yes, of course I have vec2. There we go. That's helpful. We've got our time variable here. And we are timesing it by 0.1. That's perfectly okay. So we're just going to go ahead and save, and then we're going to go ahead and run this. Now at the moment, we can't see anything happening. There is a reason for this. And the answer, I just need to remake this box. I think that's slightly bugged, so I'll have to have a look at that. Up here we have this always draw. Now typically in Wade, if you draw an image, you don't want to be redrawing it every frame. That's expensive, it slows down your app, it's just not good. But in this case, we are changing the image every frame in our shader with respect to time, so we need to tick this always draw. And as you can see, suddenly we've got a nice animation. Now just to reinforce the fact that this gets recompiled every time you modify it, if I just put something invalid like a J there, everything stops working, so you need to remember that. Now at the moment, we are just taking the color and moving it up to the left with time. That doesn't really look very good. So what we need to do is take another sample. So we are going to add one more for now. We're going to add a few more later, but really you can add as many as you'd like. It's a bit It's a bit creative, this process. You can just fiddle around with the numbers, tweak some things like this 0.01, you can change it. That'll change how fast everything appears to move. So we need to redo this, diffuse sampler, UV once again, but this time we're going to times it by, I keep doing the wrong X. Mistakes. We're going to times it by 4, and I'm just going to take away a little bit based on time. So because I'm taking away, this is probably going to go the opposite direction, or at least I hope it is. Or in fact, no, what we're going to do is we're going to multiply each component of this vector, so the x and the y component of this vector, by different amounts. Just for some more variety, we'll see what it looks like. So I'm going to go with 0.01, and I think times, I don't know, 0.5. Oh, 1.5, okay, we'll see how that works. And so now, it's a bit hard to tell, but it is actually moving. Oh, no, it isn't. I'm sorry, I have to keep making this. There we go. At the moment, we only have sample 0, so if we choose sample 1 instead, oh my, I think we need to change that. Maybe this 1.5 value is a bit too big. 0.5, 0.3. That's quite interesting. So again, just play with the numbers, see what you like the look of. Ooh. That was interesting. Lots of faded colours. So I think that's a bit better, although I'm thinking maybe even slightly smaller. No, we'll leave it at 2 for now. So the current problem we have, apart from the colours are all wrong, we can only have one of the other. Really, we want to mix these two together so we've got components moving in different directions. A bit like water. It doesn't, well, unless it's flowing in a river, of course. The whole river is flowing one direction, but individual pieces, you can find other bits, little crests of waves, moving independently, different directions. So that's what we need to achieve. And we're going to achieve that by adding some colours and mixing them together and using these different samples combined. So I'm going to go ahead down here, and in custom properties we need to make a few more. So I'm going to add a few colours. I'm not sure how many I'm going to need, so I'll just add a few for now. Colour 0, oh, these should be vec4s. Colour 1, Colour 2, and Colour 3. We might need more of these, I've not decided yet. We'll just see how it ends up looking. Just scroll down. And I'm just saving. I'm saving quite frequently. That's always good practice for pretty much anything. Anyway, we need to choose our default color values. So similarly to the vec4s up here, this is just 4 floats, but when they're used as a color, we have red, green, blue, and alpha. So let's just do color 0 first. No other colors. So we can just do, let's make it all red just for demonstration. So 1, 0, 0, 0. Oh. Alpha needs to be 1 as well. Excellent. So if I replace this SO with color 0, we just get a red screen. So I'm just showing you that it is actually taking the value here into account. It does exist, and that's what's going on. Now, we're going to create a new variable in here, vec4 C0. So this is going to be my first mix of colors, as it were. So we're just going to use the word mix. We're going to mix color 0 with color 1 and with the color of the sample, and we're going to use sample 0 for now. Okay, so this is going to mix all the colors together, so let's just set that as our variable. Now, ooh, that looks a bit demonic, all red, and that is of course because we have our color set as red. Now we're going for water, so I'm going to add in more blue, so we'll just start with 0.5 on this one. And that's very dark. Let's actually go up to 0.8, and I'm going to add a tiny bit of green just to make it lighter. A bit more. That's better. So we're starting to get some hints of, okay, this could be a fluid moving, but it's still only moving one direction. Again, we are going to address that shortly when we add our S1 to this. In fact, I'm just going to add X here. So you can multiply by the individual components. Ooh. Sorry, mix by the individual components. I quite like that, actually, that Y. That's not bad. Yeah, I think that looks quite pretty. So ultimately, we are going to do this with multiple samples. We're going to add a few more, and we want a few more colors as well. So I'm going to add one more master color for now, C1. And we're just going to mix colors 2 and colors 3. Oops. And this time we'll go with .x, I think. So let me just put a semicolon there. Now, of course, color 1 is not being used at the moment. So we're just going to quickly go change this back to color 1, which is black. Why is it black, you may ask? Well, because we haven't set these initial color values down here. So we need to set color 1, 2, and 3. So I'm going to make this quite green. That won't show up yet because we're not using it. We're using 2 and 3 at the moment. So, alright, let's make this one quite green as well. Oh, sorry, that's blue. I'm confusing myself. We'll give this one a bit of everything. And alpha 1, we want this one to be reasonably bright, but it doesn't have much color to it. That's because we're mixing all the colors, and when you mix all the colors, you get white if you mix enough of them. If you don't, you get gray or black, depending on how much you mix. So one more color. Let's make this really blue. Just pure blue. Okay, maybe a bit too much blue, I admit. So that's going to be kind of the base color. Now this is overshadowing everything else a bit, so I'm just going to lower the opacity. That's not bad. I like a bit more green. I prefer that blue. And just a hint of red. No, not that much. Yes, that's better. So again, we are only using color 1, which is a mixture of these colors and the sample we've taken. What we can do is use different components. So I could take Z instead of X. And that looks very different. I don't like that though, so I'll go back to X. Or we could take sample 1, because at the moment we are only using sample 2, so... Oh, that looks like it's flowing a bit too fast. But you get the idea. But of course, if we only use one sample, it's always going to be going different directions. Sorry, all the texture points are going to be going the same direction, because that's determined by these time values, which are sample dependent. So I know this is still very complex, but it's going to look a lot better very shortly. We're going to add a final vec4, and we're going to call it water. So, I'm introducing a new function here. This is clamp. What this does is it takes 2 parameters, and it clamps them between a value. Sorry, not 2 parameters. It takes 1 parameter, so it takes your number, and it makes it fit in a range that you specify. So for now, I'm going to take my first color. I'm going to add my second color. So now we are adding both of these. We'll be able to see them both at the same time, which is quite good. And I'm going to fit this between the range of 0 and 1. Just because if we're adding 2 colors together, say if both of them had blue value 1, that would end up being 2. And as I said earlier, we have to normalize everything. So all our values must be between 0 and 1. So I think that looks correct. I'm just going to put a semicolon here. Yes, so now we are going to look at water here. Oh wow, that is bright. So it's hard to see what's going on exactly because it's so bright. So I think we need to multiply this by a small number, about 0.2. Okay, maybe not that small, 0.5. Now notice the water's still flowing the same way. This is about to change. Watch the magic. Now, we have a much more complicated effect. It's hard to tell, so I'm going to try and slow the water down a bit, and we do that by lowering these values. And you don't have to copy the values I'm using, you can make up your own. So now, we've got the original sample, sample 0, which was moving up and towards the left, and we're mixing it with sample 1, which was moving down towards the bottom, so it makes the movement look a bit more random. I mean, even there, I quite like that. It's just a little bit dark, so I'm going to increase these colors a bit. So, there we go. Color 1 has no opacity. Let's just make that a bit brighter. So, now it's too green because we have a lot of green here. So, let's just play around a bit. Not bad. So, again, a lot of this is just preference of what you like. Now, I think this is overriding the up and to the left motion we had from here, so I think we need to, I'm not sure, maybe make this more opaque again? Yeah, that's definitely better. You can see like a hint of movement up to the top left. That's quite nice. And overall I want this to be brighter, so I need to increase all the color values really. So, oh, I'm getting confused. Color 2. So let's just go and bump these values up a little bit. And oh, that looks a lot better. I really like that. And of course you can even mix which colors go with which sample. So I can put color 2 here and put color 0 here. Oh yes, I can see kind of a ripple. I can faintly see ripples moving to the top left. I quite like that. I think that's nice. And I think we may be multiplying it by slightly lower value, so... Nope, 0.8 is too high, 0.7 is too high. Oh, that's beautiful, 0.6 is excellent. So again, a lot of this is just trial and error. Just play around with the numbers, find something you like the look of, and yeah, it looks good. That's not too bad. But of course, we aren't quite done yet. We are not far off though, ladies and gentlemen, so do not worry. We can add extra things to this. Like at the moment we've got 4 colors. This image has 4 channels. We are using 2 of them. We're using the red and the green. That's what this X and Y are. But we can add more to this, so let's just say I copy and paste this. Let's add color 2. And I'm going to use S1, and I'm going to go with Z. So that's the blue channel of that noise. And I want colors 1 and 2, no, 1 and 3, because they've not been used together yet. Excellent. So I'm just going to go and add this. Because I'm adding another color, the values of course got higher, so I'd have to decrease this. But I'm actually going to undo that. I don't like the look of that, so let's get rid of that. And I think the problem is the sample moving in the same direction, so I think we need 1 more sample just to complete the look. So I'm just going to go ahead and add that now. So let's copy and paste, make it a bit quicker. So if we base it on this one, but let's multiply by 1.5 just to make it different. And we're going to add the vector this time. And we'll make this time negative, so times by a negative number. I just want a more complex motion going on. We'll try 1. So we'll add that C2 back in, and we'll set it to use S2 as our sample. Oh, wow. Now, clearly that's had a very drastic effect. I don't really like the look of that. I think that's terrible, so we're going to undo that. Now, the problem there is clearly this minus 0.5, so let's make it positive, and let's make it really small. Let's try 0.5. Oops. There we go. And I actually want this to flow the opposite way, to the right a little bit. Yeah, I think that's quite good. It's not too bad. Now, I'm going to manually reduce the alpha of this channel because, again, it seems to be overriding almost everything. So, the alpha, we've got X, Y, Z, W. So we are going to go times equals 0.5. And that just makes it a little less obvious. Times equal 0.1. Oh, there we go. That is a lot better. So just changing that value, we've now got a nice rippling effect, but I want this to be more... I'm going to say, like, the water's going to be still. There's not going to be very much movement. I just want a very small amount. So all we do is decrease our values for the movement. That's quite good. I like that. 0.5 seems to be working well. 0.7. I'm quite happy with that. I'm just going to put this up to 0.65. No, it ruins it very quickly if I put that up. Now, of course, you could use this same technique for lava or any other liquid, really. So I'll just save our program and run because it's been a long time. We've got our nice water. Now, of course, you can spend a lot longer than I have tweaking this, but I'm doing a tutorial. It's obviously time is a factor. And we've already covered a lot of topics, so I'll just very quickly go over what we've done. Just take a sip of water. Okay, so we attached our sprite here to a scene object. We have a time value. UV alpha time is default, and so you can just copy my example here if you ever forget. And we added the screen size to preserve aspect ratio. Now, I know we've already talked about it, but I'm going to go through one of these lines from each of these sections just so you know exactly what they do. So vec4, it is 4 floats, an array of 4 floats. We take our texture, which, if you remember, just looks like a lot of crazy noise, which is exactly what it is. We look at the coordinates at our current pixel, but then we shift those coordinates by a random amount based on time. Because time changes, as long as we have always draw ticked, we will get movement. If we untick it, nothing should happen, although I don't think that's actually worked correctly. I'm going to have to check that. But make sure it's ticked anyway, it's just good to be safe. You don't want way to optimize all your beautiful shader code away. So that produces our movement. The color is coming from, we are mixing the color this provides with the color we define here. So we can change this. We can even change the color as it runs. We probably don't want to do that, but let me see, color 2. I've got to be a bit careful here by what I multiply. Not sure it's a good idea. I'll give you an example. I'll quickly multiply the opacity of this layer. So remember we made the final mix really dim because otherwise it took over everything and you couldn't see much. So what happens if I multiply this by time? It's just going to get bigger and bigger because time, well, is just increasing as the program runs. So if you want to get around that, you can do sine of time. Now, if you've seen a sine wave, you know it goes between +1 and -1. And so, yeah, you can see it fading in and out. So obviously you can make some really cool effects if you want. You can get very complicated, and I encourage you to just play around. It's really fun. Just mess around with the values. Have a good time. See what looks good. Now, I'm just going to put this back to 0.1. Maybe even lower. I can't quite decide. Alright, 0.1. I tell you what, we're going to change this C1 value as well, because I think it's a little bit too dominant. So we'll change the alpha of that times equals by 0.5. And again, whenever this happens, it means the shader's invalid. You've made a mistake, so we add our semicolon. I quite like that, but adding all this alpha means our result is getting dimmer, so we need to increase the multiplication here. That's quite nice, but let's go to 0.67. Yes. And I don't actually quite like the color. I think I want to tweak the color a little bit, just playing around. I really am playing around too much now. You get perfectionist a bit if you start messing around with this. You can go crazy just with whatever you need. Oh, I like that. Can you almost see those do look a bit more like ripples with that color? So just play around, tweak the values, and see what you can produce. I might actually keep doing this for a while after recording this for you because it's quite fun. Oh yes, I see that. That looks quite good. I really like that. I'm just gonna go and play with these colors, see if I can make any magic happen. Ooh, that made a really green theme happen. I think we've got too much green. Let's remove some. And then let's, I don't know, 9? Oh no, I don't like the purple. Let's keep red low. And color 3 will just, ooh, that made a big difference. But you see how little it takes. You just tweak small values and you can get completely different looks, and it's really fun. About a lot of red there. No, a lot of red doesn't seem to be looking good. I mean, you'd expect that water is generally not red. I'm sure if we were making a lava texture, this would go quite well. But for now, I think I'm going to stop playing around with it and I'm going to leave it there. So, hopefully you enjoyed the tutorial, guys. You can see just a lot of playing around with values, really. Once you've got the basics, and it's not much code. I mean, 18 lines of code, and you can make things look completely different just by playing with the numbers.